Hi, we have come to question 3. Now question 3 have got 3 parts, but what is listed here is the part 1 and part 2. Now for question 3, you are given 3 functions f of x, g of x and h of x together with its domain. Now part 1, you are asked to show that f is not a one-to-one function, and if x is greater than a, f is a one-to-one. Then you are asked to find the least value of a. Now let us show that f is not a one-to-one. Now to show that it's not a one-to-one is pretty simple. You can do the horizontal line test, but we must have the graph of f. So to do that, you just key this function, all right, together with its domain. But in this case, the domain is a set of real numbers. All right, you just key this function into your graphical calculator. And how will the graph looks like? Okay, let us quickly draw it out. Now, if you look at the graph, all right, it has a vertical asymptote of x equals to 2. Now, what is the horizontal asymptote? The horizontal asymptote, without the mod, you find that it is minus 1. With the mod, all right, minus 1 then becomes 1. So you have a horizontal asymptote at y equals to 1. All right, so the graph, if you key in, it will look something like that. Okay. Now you find that this part is 3. All right, this is f of x. Now how to show that it's not a one-to-one? You can use a horizontal line test. Now this is the line y equals to 1. Now, so if we draw a line between 0 and 1, you find that it cuts the graph more than once. All right, let's say we draw a line y equals to 0.5. Anything between 0 and 1, you find that it cuts the graph twice. So now, we can explain that a line y equals to 0.5 cuts the graph f of x more than once. Implies that f of x is not a one-one. Now, what is the least value of a such that the function is a one-to-one, x such that x greater than a? What is the least value? Now, if you look at this graph, you realize that now if we restrict the domain such that x is greater than 3, right? Anything greater than 3, then the graph is a one-to-one. All right, so if take for example, we take this part of the graph, let's say this is 4. All right, you find that when x is greater than 4, it's a one-to-one. But you want the least, all right, so will be 3. Okay, so a is equals to 3. Okay, now let's go on to do part 2. Now you are asked to find the F inverse. Now to find the F inverse, now look at this graph. This is a modulus graph, all right? Or rather, we are asked to find the F inverse when x is greater than 3, all right? Because we found that a is greater than 3. Greater than or equals to 3. Now this is a modulus graph. Now when x is greater than 3, you look at this part, all right? So maybe when x is greater than 3, we want to see whether 3 minus x over x minus 2 is positive or negative. All right, so when x is greater than 3, 3 minus x over x minus 2. Let's say we put 1,000 here. But let's say when x is equals to 1,000. So the top will be negative, the denominator will be positive. So right, so 3 minus x over x minus 2 is negative. All right. So when x greater than 3, your f of x will be equals to the negative of this, because this is a modulus, all right? This is negative. So modulus will take the absolute value of the number, all right? If this is negative, so your f of x will be equals to minus 3 minus x over x minus 2, all right, when x is greater than or equals to 3. Now to find the F inverse is very simple. You just equate y to it. So the top will be x minus 3 over x minus 2. Now if you do a cross multiply, you will have y x minus 2y equals to minus 3 plus x. Okay, if you bring the minus x over and bring the 2y over, you divide, you will find that this x will be equals to minus 3 plus 2y over y minus 1. Yeah, y minus 1. Okay. So your F inverse will be equals to, therefore, F inverse will be equals to minus 3 plus 2x over x minus 1. What about its domain? All right, the domain of F inverse. Now the domain of F inverse will be equals to the range of F. Now the range of F is between 0 and 1. All right, so your F inverse, the domain of F inverse will be between 0 and 1. Must not include 1 because 1 is an asymptote of the function f. All right, so the range doesn't include 1 when x is greater than 3. All right, so here will be, therefore the domain of f inverse is smaller than 1. Smaller than 1. Now this is not there. Okay. Now we have finished part 1 and part 2. We shall now move on to part 3 of question 3. Now we have now come to part 3 of question 3. Part 3 of question 3 uses just g and h of the 3 function. Now it is given that g of h exists and the range of g of h is between ln 4 and ln 6. You are asked to find the exact value of b. B is involved in the domain of H such that X is greater than minus B. Now there's two ways to approach, at least two ways that you can approach this question. If you look under the video that I did for composite function, right, there's two ways to determine the range of a composite function. Now you can try them out, but for today, I will just use method 1. Both will arrive to the same answer. Now the method 1 uses the rule of the composite function. So let's define the rule of the composite function. G of H, you put H into G. All right, this is H, you put it into G, so you have ln 4 plus e to the power of minus x. Now next, you put this graph into your GC to see the nature, because this graph may have turning point, we are not sure. Because if they have turning point, it will affect your answer. Now, so you put it into your GC, your graph looks something like this. All right, you will find that the graph has a horizontal asymptote. All right. Now let's determine what is the horizontal asymptote. As x tends to infinity, g of h tends to ln 4 plus. So this is ln 4. Now you put x equals to 0 to find where it cuts the y-axis. So you find that this is ln 5. And the range is given to be between ln 4 and ln 6. So let's say this is ln 6. Now let me name this graph first. This graph is ln 4 plus e to the power of minus x. Now your range of value is such that it is between ln 4 and ln 6. So this is ln 6. All right. So your range is somewhere here. All right. It is given that the range of this domain, of this function, all right, is given as such. It's between here. Now, so what values of x must it take? Now, you must, let's say I call this x1. So from the graph, your input must be greater than or equals to x1. All right? Because if it's greater than x1, you will find that your range is between ln 6 and ln 4. Your graph is in between ln 6 and ln 4, not inclusive of ln 4. All right? So your domain of this function must be, x must be greater than x1. But what is x1? This value of x1, when you put x1 into this function, you get ln 6. So what we can do is we can equate this function equals to ln 6 to find out the value of x1. So you inverse ln both sides. So e to the power of x is equals to 2. Then minus x will be equals to ln 2. X will be equals to minus ln 2. Now, so if you do a comparison, all right, with this is the given domain in this. So you find that b is equals to ln 2. For that, we come to the end of the question. Thank you very much.